So here I just wanted to do the variables separate. So this is a same topic, but here you can see, oh, we got letters and we're still doing it. That's fine. We can still work with this with letters, okay? So the first three that we gave you were numbers. These have letters. But again, the first step is not say like or unlike, because right off the bat you probably say, nope, can't do because x cubed and x is different. You got to see if you can simplify. So how do we simplify x cubed? Remember, it's harder to do a tree diagram when they're letters. So I always told you, you need to get rid of the exponent. So don't put it in exponential form, put it in factored form. You know x cubed means that we have 1, 2, 3 x's. When I have 3 x's, and remember, since this is still square root that we're doing socks, do we have any pairs of socks? Even though I have 3 of a kind, remember we're doing socks. So we only need 2 of a kind to make a complete set. So anytime that you have 2 the same size, remember, ball them out, that becomes 1 pair of socks. When you take them out, it just becomes 1 set. So this can simplify to be that 1 sock that couldn't match, and this 4 and the x on the outside away in your sock drawer. What do we do with them? We multiply. 4 times x is 4x. How about for the other one? Yeah, I can't break down square root of x. Can't do a tree diagram. Doesn't have an exponent, so there's no sense in me putting it in any other format because it's already not written in exponential format. So let's bring it down, and you can see these match. Square root of x, square root of x. So you do have matching ones only if you simplify. Once you realize who's what's it's, they're the same label, keep it the same label, who's it's, that's square root of x. Then we only have to look to combine these guys that are on the outside, the coefficients. This is a positive 4x, this is a negative 2x. You know 4x and 2x have the same variable parts, so you can collect. 4x minus 2x is going to be a positive 2x. So this and this can reduce down to 2x square root of x. Let's do one more of these letters so that you can see that if it's numbers or letters, variables or constants, you can do the same thing. So one of the more harder problems to do, but again, we've learned how to do this with numbers and letters. So it doesn't matter if this has lots of letters and numbers. The first thing that you want to do is see if you can simplify. So look at the radicand. Since they're going to be all monomials, ask yourself, can you break that down? Most of you probably said, well, I know I can break down at least the 54. 6 times 9. And this is really 2 times 3. And 9 is 3 times 3. So you can break down the number as 2, 3, 3, 3. But how about these letters, a to the 5th? Instead of keeping the exponent, exponential form, write it in factored form. Just means write out 5a's. When you have 5a's, again, what are we doing? We're matching socks. Socks are this. So we got a pair here. Remember, we're looking for the same size, same color. Don't do a 2 and a 3, they're not the same size. Do the 2 3's. And here, do the 2 a's. And then you have another pair of a's. So these go away in your sock drawer. Remember, even though there were 2 socks, they become 1 unit or 1 set. So what's left is this 2, the 3, and this A that's still in the basket that couldn't pair up. So 2 times 3 is 6 and an A. Now what's on the outside? A times 3 times A times A. Well, you know 8 times 3 is 24, and A is 24A squared. Now let's see if we can break up the other side. So notice 24, most people break it down as 4 and 6, which is 2 and 2, 2 and 3. Alright? Break down A cubed, 1, 2, 3. Now notice this 3A is still on the outside. So do we have any balls of socks that we can pair up? Yes. These 2 can pair up. These 2 can pair up. So then what you can do, put them away in your sock drawer. Remember, they become 1 set. So what's left that's unmatched in the basket? The 2, the 3, and the A? Or if you multiply them, 6A. What's left on the outside? What's away in your sock drawer? 3A times 2 times A. Well, 3A times 2 is 6A times A is 6A squared. So if you have 24A squared times square root of 6A minus 6A squared times square root of 6A, what you just got to realize is that these are like terms. The same radicand, 6A, the same roots. Square root, So, whatchamacallits stays whatchamacallits. These that are outside the radicand, remember your coefficients? Can we combine 24A squared with 6A squared? Yes, because they have the same variable part. This is a positive, this is a negative, so we'll subtract, and we'll get 18. And remember, A squared stays the same variable part, A squared. So even though this and this didn't match in the beginning, if you simplified, they do match, and then you could combine.